Hello everyone, welcome you all to the next video on set theory. In this video, we will be discussing about Venn diagram and its uses. In the previous video, we have seen the different operations on set, union, intersection and all the others. So we will try to relate those with this Venn diagram. So first, let's understand what a Venn diagram is. In the second lecture, we have discussed the representation of sets, in which we have seen that there are two representations. One is the roster method, another is set builder method. However, there is another representation of set, which is the Venn diagram. Means Venn diagram can be represented by using some diagrammatic method or using some symbols, using some notations. So that is called Venn diagram. Venn diagram, basically we use symbols. One is the square symbol, which represents universal sets, and all the other sets are represented by using the circle. So we will be using these two symbols while representing sets using Venn diagram. So let's take an example. Let's take the example of a universal set U having elements 1, 2 till 10. Another set A having elements say 2, 3, 6, 9. A set B having elements 6, 9, 8, 10. So what is a Venn diagram? So we will represent this sets. This is U. This is the universal set. The two sets A and B. Observe that the sets A and B are having common elements 6 and 9. So 6 and 9 are the common elements between A and B. So these common elements will be inside this. So it will contain 6, 9 and rest elements 2, 3 and what are the other elements in B? 8 and 10. So 8 and 10 will be placed here. So this is A and this is B. So this is the way of representing set using Venn diagram. Now, what does this question represent? This question represents the common elements between both the sets. However, this question represents the universal set. You can say if 1 till 10, out of those elements, sets are those elements which are in A are represented by this. Those sets which are in those elements which are in B are represented using this, and the common elements between A and B are put inside this word. This is for sets. If you have three sets, what you can do is that, for example, A, B, and C. Let's take three sets. One is A, one is B, another is C. So, this portion, the portion that is common, this portion consists of all the elements, of all the elements which are common to A, B as well as C. However, those elements which are common to A and B will be placed here. Similarly, those elements which are common to A and C will be placed here. Elements common to B and C will be placed in this portion. So, this way we can represent sets using Venn diagram. So, this basic idea behind Venn diagram. So, the set is represented by square bracket by the rectangle, and the circles represent the sets. Sometimes it may happen that there are sets which are disjoint. Let's take an example. Say we have another set, say C equal to, we have in A 2, 3, 6, 9. Let's just consider another set C having elements 1, 4, 5, 8. So represent A and C using Venn diagram. So the set A is containing elements 2, 3, 6, 9. Common elements between A and C. So we have to put it by 1, 4, 5, 8. So in that case, we can consider that the set A and B are disjoint sets. So in disjoint sets, there will be overlapping elements, there will be no common elements between them, and therefore they are placed separate. However, if we have some common elements, we have to put them inside this part, inside the middle part. So that's all about Venn diagram for sets, even for three sets. Now let's link it up with the different operations that we have seen in the previous video. Let's consider this as an example. Asked to find. So there are different operations. The first operation is A union B. So what is A union B? B is from the Venn diagram we can see all the elements there are considered as A union B. So 2, 3, 6, 9, 8, 10. Order may vary. These elements, all the elements comes under A union B. Intersection B, we have to see the common elements. So 6 and 9, the elements that are placed here are considered as intersection. So this portion is the intersection and the entire thing is union. Next comes intersection, which is the set difference, which is A minus B. So how can you find A minus B? A which are not in B. As we have seen in the previous video, elements of A which are not in B comes under set difference. So elements that are in A but not in B, on the Venn diagram it is clear that 3 are inside A but not inside B, because 6 and 9 are inside A and B, but 2 and 3 are inside A but not in B. So A minus B will be 2, 3. Similarly, B minus A. B minus A means elements of B which are not in A. So what are the elements of B? 6, 9, 8, 10. However, 6 and 9 are in A also. So therefore, 8 and 10 are considered as B minus A. Next comes the difference, A delta B. So what is A delta B? Common elements, all the other elements comes in A delta B. That means 2, 3, 8, 10. 3, 8, 10. 3, 8, 10 are the elements of A, symmetric difference B. So in other words, we can say it is an A minus B and B minus A. So that's the way of representing different operations using Venn diagram. For Cartesian product, we can't use Venn diagram directly, but we can make the two sets and we can connect the elements. So however, for the basic operations, we can use Venn diagram. So these are the basic operations, basic uses of Venn diagram. So this is how we can represent sets using Venn diagram. I hope the concept of Venn diagram is clear. We have included Venn diagram here separately so that the concepts remain distinct. If there are three subsets, the common part will be represented. We can also be represented. So, based on this, let's put a query. So the question is, Let there be three sets. One is the set U, which is the universal set, 1 till 10. There are three sets, A equal to 1, 2, 3. The set B consists of elements 2, 6, 7, 8, and the element C consists of 2, 3, 5, 9. So represent them by using Venn diagram. Represent using Venn diagram. So with this, I hope the concepts of Venn diagram will be clear. So I expect you all to answer this in the comment box. So thank you all for this video. In the next video, we will be looking into the different postulates, different rules that we can use in set theory. So thank you all. Thank you very much.